Today, we're going to learn state of matter under thermodynamics. So, good day to all students of our respiratory physics. No, so why we need to study the state of matter? This is a very a review. No, so I do believe that the topic of thermodynamics has been taken. No, nakuha nyo na ito before when you are in your senior high. No. So this is only a review, no? So as a respiratory therapist, we need to study thermodynamics, no? A review, no? Why it is very important to study this state of matter. So basically, we know that there are three primary states, no? So what are the three primary states, no, of matter? So we have solid. So that is the molecular structure. They are more intact. When we say solid state of matter, the molecular or the atoms are more fixed. No, they do not move. It's intertwined. No, so this is the visualization of how the structure looks. No, of a solid uh, matter. So then the liquid state. So they can be ma-move sila, like tightly loosen, no? So that is the liquid, no? And then we have the gas. So gas is more compressible. It's they move freely. They have this more spacious, may mga space sila. So this and others are plasma or blood or other body fluids, no? So this is clinically, no? So in our profession, it's not only the basic, the solid liquid state. We consider also a plasma, which is near to liquid form of state of matter. So we're going to review the internal energy of matter. So there is an internal energy in a matter. So because there is an atoms, no. So atoms make up all the matter. So lahat ng ating mga all matters are composed of different atoms in simple definition. And or are in all these are in constant motion. They move, no? There is an energy moving these atoms. So at constant motion and normal temperature. At normal temperature. So the movement at normal temperature is there is a constant movement of atoms, no? So then this motion is resulting from internal energy. So this is what there is an internal energy in our atoms, no? So there are two major types of internal energy. One is potential and the other is kinetic. When we say potential energy, this refers to as energy of position. So that is object balance. So when we say potential energy, is a result of a strong attractive forces between molecules. These intermolecular forces are why solid are rigid. So liquids have viscosity and cohesiveness. So these intermolecular forces are not strong in gases. Hindi sila ganun ka-strong, no? So kinetic energy is the energy of motion, such as falling object. Most internal energy in gases is in form of kinetic energy. So more on movement. So laws of thermodynamics. So laws of thermodynamics. So the term thermodynamics can refer to either the science studying the properties of matter and various temperature, or the kinetics of reaction of matter and various temperatures. So these are factors, no? You need to study the science of matter. how temperature affects, how kinetic energy affects to the matter. So that there is will be a reaction over these external forces towards the matter. So the laws describe how fundamental uh, physical quantities such as temperature, energy, and entropy uh, behave under various circumstances and forbid certain phenomena. No? So a basic knowledge of this principle is helpful in understanding many aspects of respiratory care. So we are dealing with a solid matter, with the liquid and the air and the gas state. So when we say solid, so it's pertaining to the anatomy or the structure of your trachea. When we say liquid, it can correlated to your secretion, no? Body fluids, blood. When we say air, gas, it can refer to the air, the carbon dioxide, the oxygen we breathe in and out of our lungs. So that's very simple. And how we correlate the states of matter to our respiratory care practice. So, of particular interest is the first law of thermodynamics, one version of which states that an increase in internal energy of a closed system can be result only of work performed on the system. So work can be viewed as a process of transferring energy to or from a system. So the increase in internal energy of a system can be observed as an increase in heat as with humidity, humidifier, or pressure as during mechanical ventilation. So correlation with your clinical application of this thermodynamics is your humidifier. So in your ventilator, there is an device we call it humidifier. It heat ups the air before go from the ventilator before going to the lungs. So it applies the principle of thermodynamics. The second is when we ventilate patients using a mechanical ventilation or mechanical ventilator, we put pressure on the gas so that they can how we can deliver and we can compute how fast is the gas can be delivered or the pressure can be applied to the air going into your lungs. So this particular procedure or respiratory care practice is uses the law of thermodynamics. So these are elements that is very important how thermodynamics can be applied to respiratory care procedure. So we have different transfers. Now, heat transfers between two objects at different temperatures. So the first law of thermodynamics tells us that the heat will be moved from the hotter object to the colder object until the object's temperature are equal or equilibrize or magkaroon ng equilibrium towards the temperature. So this is the first law of thermodynamics. So heat will move from hotter object to the cooler object until object temperatures are equal. This is an example of transitioning from higher states of energy to a lower state. So two objects with the same temperature exist in thermal equilibrium. So that's the simplified definition. Heat can be transferred in four ways. One by means of conduction, second is convection, the third is radiation, and the fourth is evaporation and condensation. So what is conduction? So heat transferred in solid occurs mainly via conduction. Very basic, no? We define conduction as a transfer of energy by direct contact between hot and cold molecules. So how will heat transfer by conduction depends on both number and forces of molecular collision between adjoining objects. So there is a contact sa conduction. So another one one form of heat transfer is by means of conduction. Second, heat transfer is by means of convection. Convection is heat transfer in both liquids and gases occurs mainly by convection. Convection involves mixing of fluid molecules at different temperature. Although air is a poor heat conductor, again, the air is a poor heat conductor. So it can efficiently transfer heat by convection. To do so, the air is first warmed or heated in one location and then circulated to carry heat elsewhere. This is principle behind the force of air heating in house and convection heating an infant incubator. So fluid movement carrying the heat energy are called convection currents. So one typical example is you can see incubators of the baby or newly born baby. We call it neonatal in your intensive care unit. So the baby is put in an enclosure or closed environment, which is called the incubator. So that the heat transfer, the science is called convection with the use of enclosures or infant incubator. The next is radiation, another heat transfer by means of radiation. Radiation is another mechanism of heat transfer. So conduction and convection requires direct contact between two substances. Whereas radiation, heat transfers occur without direct physical contact. Wow! So typically invisible. Hindi mo nakikita na there is no possible physical contact. You cannot see two object meeting each other or contact, no. So heat transfer rarely occurs even in a vacuum, such as when the sun warms the earth. So sometimes they cannot see in these waves. There's gamma waves. To this radiation, hindi mo sila nakikita that there can be a possible heat transfer via radiation. Common is yung sa ating microwave, di ba? So there is a radiation energy going to your food inside your microwave. So evaporation and condensation is another form of heat transfer. So vaporization is a change of state from liquid into gas. So vaporization requires heat energy. So you can only create or produce or um, what we call this experience or initiate vaporization when there is the presence of heat energy. So according to the first law of thermodynamics, so heat energy must come from the surroundings. In one form of vaporization called evaporation, heat is taken from the air surrounding the liquid, cooling the air. In warm weather or during strenuous exercise, the body takes advantage of these principles of evaporative cooling by producing sweat, na nagpapawis yung tao when we do exercise because we burn energy, we produce repetitive motion that produce energy or nagkakaroon ng warm ang muscles natin that produces sweat ano tayo, nagpapawis yung tao. So the liquid sweat or this pawis evaporates and cools our skin. So that is the typical example of evaporization and condensation. So pag you do exercises. So condensation is the opposite of evaporation. So in condensation, gases become liquids. So kanina gases become opposite niya, 'di ba? Liquid become gases. Here in condensation, gases become liquids because vaporization takes heats from the air around the liquid, no? And then condensation must give heat back to the surroundings, or we call warming. So a refrigerator, air conditioner is one example that wherein condensation works. So the principle, no. So on the principle of repetitive vaporization cycle. So the refrigerant warms in, for example, typical example of our refrigerator, there is a refrigerant, no. So warms, vaporizes, and expands the characteristic of your refrigerants. Then a compressor condenses the refrigerant again, releasing heat that is carried away to the atmosphere by radiator. So you can see uh, basically some small pipes no sa iyong refrigerator. But these small pipes with now inverters type of refrigerator cannot be seen now in latest model no. So because of this technology la iba na. So the condensed refrigerant passed through the food and the cycle repeats na paulit-ulit. The whole system is basically heat pump transferring thermal energy from the food to the atmosphere. So temperature and kinetic energy are closely related. So temperature is measurement of heat. So heat is the result of molecules colliding to one another. So that is the effect of a temperature. So the temperature of gas, with most of its internal energy spent keeping molecules in motion, so is directly proportional to the kinetic energy. In contrast, temperature of solids and liquids represent only part of their total internal energy. So directly proportional ang temperature sa kinetic energy. So when we say absolute zero, it's a concept wherein fini-freeze natin ang movement ng atoms. So because there is no energy, the molecule ceases to vibrate, no vibration, no movement. So the object has no heat. It can be measured, walang temperature nga ma-define to the absolute zero. Although researchers or scientists have come close to this attaining absolute zero, but no one has actually achieved in this study. So this is due to the third law of thermodynamics. What is the third law of thermodynamics? Which states that absolute zero is impossible to reach. Again, absolute zero, even researchers and scientists has wala sila nakitang at they don't attain the absolute zero experiments. So no one has actually achieved this. So it's because according to the third law of thermodynamics. So remember this, that which states that absolute zero is impossible to achieve. So this is the formula or equation to convert Fahrenheit, degree Celsius into degree Fahrenheit, and degree Celsius. So you can see it at the physical principle respiratory care chapter 6 now of your fundamentals. So this is the table corresponds to the kinetic activity in relation to your temperature. So we may say it's an alpha sign. The kinetic activity or pressure is directly proportional to your temperature. So the higher the kinetic energy, the higher is the temperature. That's what the data wants to tell us. So that's for our thermodynamics, the laws of thermodynamics, and probably a review of different states of matter. So we embrace these fundamentals of law of thermodynamics that is a very basic foundation to our daily practice in respiratory care because to recap, the states which represent the solid, the liquid, and the gases can directly be correlated to our respiratory care procedures. So, pag sinabing states of matter na structure, ano ang behind principles in terms of thermodynamics and laws correspond to the science of solid states of matter, represent your airway structure, your anatomic airway, that is your airway or trachea, represent the solid states. The liquid represent your secretions or mucus or other body fluids or such as secretion, bloods. So, yun ang nagre-represent ng liquid, how liquid represents. So, it represent cohesiveness, medyo slight mobile ang atoms or molecules. Let's say liquid states, and air represent our air or gas forms. The third states will be what we call the gas states of matter, which represent your air we intake going, so can be correlated to oxygen, carbon dioxide, no, and other inert gases or lightweight gases, no, that represent our fractional functional residual capacity of, or FRC, no, of our lungs. So that's why ang lungs natin hindi nagko-collapse because of this behavior of the third state, which is the gas states of matter, so which is represent can be directly related or to be directly correlated to your characteristic of an air or oxygen, which is compressible, no. So that is for our topic, thermodynamics and states of matter. So please review again your EGANs. So all these table topics are taken from your book, and please do advanced reading for this for these chapters. Thank you.